Wow, we have a lot of attendees tonight. So get ready, turn on your camera. We will have a quiz tonight. Right, Professor Kwok, where are you? You're still there, right? Yeah.
I'm still here.
We're having a quiz, right? That's the plan.
Hello, hello.
I said we're having a quiz, right? We need to turn on camera.
Sure, you're the boss.
Well, thanks for joining us, everybody. Again, welcome to Kwok Talk. Professor Kwok kindly volunteered to host one of our IEEE speaker event. So he'll be answering questions about RF engineering as a career, or any other questions that you guys have. Feel free to ask him. So I'll let you take the floor, Professor Kwok.
So is that too noisy here? I mean, can you guys hear me? I mean,
You're fine.
It was okay, okay.
On my side.
Yeah, we can hear you fine.
Good. So are we ready?
I am. I mean, I have my camera on. I have my calculator ready.
Okay.
Yeah, I'm ready.
All right. So so this is very informal, right? The whole idea is I want to introduce you to RF engineering, what it is. And so I'm just going to briefly talk about this a little bit for a few minutes. And I invited a few former students. I see Sam is here. I don't see Alex yet though. So they are former students within the last few years. They finished 140, 172, and they went on as RF designer, engineering, started off in this Bay Area. And so I'm gonna ask them to share their experience and on the view of the industry in general, and also from a student point of view, is that a good idea to go into RF engineer as a career? So of course, if you ask me, I will say yes. So let me briefly introduce RF engineers. Like what do we do, right? What does that mean? And is that a good career? I mean, yes. Why is it a good career? And what is the future outlook like for wireless and microwave and millimeter wave engineering? So to me, RF engineer is really the transport of signal from one place to another. It's a physical transport of this signal. It's very analog, even though the scheme might be a digital, but it's a digital signal riding on RF, on the analog signal, on the electromagnetic wave. So so you can think of it, there's like 4 different types of systems. They can be broadcasting, like just sending out signals, like the typical radio stations, TV stations, or the beacons for navigations. Like every airport, right, they have a beacon frequency. So when the airplane get close to it, they receive the beacon, they know they are nearby whatever the airport is, or the satellite, or a lot of ports have that too. The system can be purely receiving, like the GPS receivers we have on our cell phone, for example, right? We're not talking to the GPS satellite. We are just receiving a signal. Or nowadays, Zetcher, very popular, is for astronomy to use RF signal, to use microwave, to listen to deep space, to try to see something or learn something that we cannot otherwise see, right? In the old days, we only study astronomy using optics, whatever we can see with our eye, with the frequency spectrum that we can see. But now, people realize, wow, the microwave spectrum actually give you a lot more information. So you see the picture down below is one of the satellite. It's one of the antenna array pointing to deep space, and just listen and see, what we can learn from listening. There are passive detections, pretty much like a submarine using sonar, just listening. And people can monitor our conversations, whether you want it or not. And there are some passive guiding of missile using listening to the instructions. Right? There are systems that are both send and detect. So radar is a typical example, right? You send a electromagnetic wave out, and you shut down, and you listen. So that's you send and detect the reflections. RFID is more or less based on the same idea, except RFID can come back with an ID number, and also you cannot turn off the signal, because if you turn off the signal, the ID would not respond. So similar, send and detect. And then of course there are two-way radios. Cell phone is one of them, Wi-Fi, and all the communications, right? If you look at one of the cell tower, like the one I have in the picture here, you know how busy our airway is already, right? So there are many within RF scope. There are many things to choose from, right? So let's say if you want to design let's say a satellite, a direct TV type of project. So you need to have a system architect to design, what the ground stations should look like, what the satellites should have, what kind of characteristics, right? And then what size of the dish, what kind of receiver. There's a lot of things involved in it. And of course, there's subsystems design. Let's say in your satellite, you have to have an up and down converter. So just by itself, it's a smaller system, but even then, there's a lot of components in it. And so there you have components design, you have amplifier, mixer, filter, power divider, a lot of these things. And then you have to have a project management or payload management. You have application engineers that need to know the technical stuff to relate the design engineering work to sales and marketing, for example. You need manufacturing engineers who has to have the technical details to bring the design to manufacturing. You have test engineering for specific test requirement, and so on and so forth. Now, you can be jack of all trades. You can know a little bit of everything, which is what typically system engineers do, right? They don't need to design any components per se, but they know a little bit of everything, so they know how to put the system together. Or you can be a master of one, right? If you say, okay, I just want to do amplifier, that's all. It would be a lifetime career already, right? Amplifier, well, yeah, just amplify. You say just one thing, but there's a lot of different requirements, right? Can you get more gain? Can you do wire bandwidth? Can you do more linear? Can you withstand a higher temperature? There are all kinds of requirements, right? Different frequency, wider bandwidth. So you can just take one thing. I want to be oscillator guy. So you learn how to do crystal oscillator, VCO, DRO, all kind of oscillators. And that would be a career by itself. I'm sorry. I couldn't hear the question. Was that a question? Okay. So, but the nice thing is our experience is cumulative. What do I mean by that? Well, I mean, Maxwell equation doesn't change, right? And it's not going to change anytime soon. So whatever your experience is, it would be still working when you get to a certain, when you get older. It's not like software engineer at a certain age, what you learn is being obsolete, and people would much rather hire a junior engineer than keeping you. So as far as the market, I mean, if you think about it, it wasn't really that long ago before, at a time where we do not have cell phone, we do not have World Wide Web, we do not have GPS, we don't even have PC, right? I mean, it's really a workstation at that time. No Google, no Amazon. It's not that long ago. And at that time, you know, what we have in terms of RF engineer would be like radio stations, TV stations. People make ham radio equipments. We have satellites, military and commercial. We have communication. I mean, that's pretty much what the market was at that time. And it was very busy already. I mean, there's a lot of geosatellite going up at that time. And of course, we have more radio, TV stations, direct broadcasts. That means which require satellite services. And then since then, we have internet, we have open GPS, we have direct TV, broadcast, Wi-Fi, iPhone, iPad, you know, a laptop, all those connections there. You know, things just got so much more busier. And then we have on-demand radio, on-demand movies. All those require a lot of connectivity, right? And a lot of these connectivities are wireless. No one wants to do wire anymore, right? And then we have medical devices are getting more and more wireless. You know, the MRI is all in radio frequency. The pacemaker, they're communicating to the signal, the data broadcasting out in RF. The RF applications in medical devices just increases exponentially since about 2003, around that time. And then we have companies like Amazon, Google, and Facebook. They are typically not RF company, right? But if you go search for jobs, they all hire RF engineers, right? Amazon, of course, they have their Kindle, they have their, has to have wireless connectivity. They also are gearing up on RFID, you know, management system and all that. Google used to have a satellite company, right? A smaller satellite company. Facebook, they are into VR and AR, of course, you know. And then you have ASIC type of company like Intel, AMD, Cisco's, I mean, switches. They all hire RF engineer because they have something called signal integrity, which is a transmission line theory, which is what we learned in the last chapter in 140 or the first chapter in 172, right? And then of course, Apple and Samsung, Nokia, those are phone companies. Of course, they hire a lot of RF engineers. Walmart and Target, you know, they are not RF equipment manufacturer, but they hire, you know, RF engineers because they have to gear up. They already had gear up RFID for their inventory control and logistic moving boxes in and out. And then there's a list of companies that typically are not RF manufacturer, like Applied Material. They hire a lot of RF engineer because they make semiconductor etching equipment, and in there they have to be able to move the plasma around, which they require electromagnetic wave understanding of how to move charges using electromagnetic wave and impedance matching, that kind of thing. And then of course, ADT, security, sensors, surveillance are getting more popular. Now out of all this, I mean, there are drones, you know, of course they are flying. CubeSat, there's gear for smaller satellites. And astronomy, already mentioned. The other ones, I think, is like they're really big. IoT is big. IoT, because now we want to connect everything with everything, right? So, like I said before, in a typical, let's say, in a typical manufacturer that make light bulb or light, for example, in general, right? Usually, you don't need RF engineer. You might need an electrician, yeah, but But now, because we control the light with a cell phone, we can change color, we can change mood. You know, everything has to be connected to the internet. The refrigerator manufacturer, they now have a flat panel right on the front door. So everything has to be connected. There's so much sensors involved. There's so much connectivity involved. They all
Professor Kwok,
yes.
you said there is no emerging market for cell phones, GPS, and Google nowadays.
Hello?
Did you say there's no emerging markets for cell phones, GPS, and Google nowadays?
No, I say this, these are new emerging markets.
I see.
And so now, you know, like refrigerator company, they have to hire RF engineers, right? So all the appliances company, appliances manufacturers, they used to not having to need an RF engineer. Now they all do, right? So that's huge. The market is huge. 6G is coming up, you know, so all the equipment has to be updated. That's huge. Auto driving, right? So now, yes, we have auto driving already, but we are not nearly to where we need to be. So that we still have cars that can auto assist, not auto driving, right? Because it still depends on opticals, but it still depends on recognizing the road. A future auto driving autopilot would be not really based on optics, but based on RF, right? So think about wire optics, right? I mean, the equipment doesn't see, so they use RF to guide. Like if we think about if you have sensors along the road or on the roadside, when your car passes by, you download all the informations, right? It's a lot more efficient and a lot more safe. So this also is huge. Right now, it's already huge. There's a lot of millimeter wave sensor in the car already, but it's going to be a lot more. The other industry, I think it's going to pick up a lot is the gaming. Gaming right now is not, you know, we start getting into 3D virtual reality thing, but I think in the future, gaming and entertainment and movies is going to merge. So you're going to be part of the game, really inside the game, or part of the movie, inside the movie. So I'm really looking forward to that. So now, why is that a good career for you? Demand and supply, right? The demand just keep going up like crazy. We have so much more application coming out every day, right? So many new business proposal, any new system, no one's going to use wire. Everything is going to be wireless, right? And we have more and more people connect to the internet and also to the web in general. So more application, more usage, a lot more people in the rural area are going to connect to that. We have IoT. We have a lot more applications and jobs than we have in our RF engineers, right? Right now, it is really a good time to get in because just the companies I work with and I know of, no one had enough RF engineers. They all are constantly hiring. Some are more experienced, some less, right? And because we don't have enough engineers, companies are willing to hire you and train you as a design engineer. And we have very limited supply, right? RF engineer, I think, is one of the higher barrier to get in because you have to go through a lot of math. Just think about 140. Just think about, right, 172. I mean, not that many people has the amplitude for it. And overall low enrollment in this type of courses. I mean, everybody knows software engineering make a lot more money. It's easier to get in, right? Doesn't require you of all this math And so of course, I think like almost 70% of the students will go into, or STEM student will go into software or want to go to software. So the number of people going in is less, and number of students getting into RF and microwave is even less. You can talk to Alex and Sam later. Most of engineers in the field, they are either, I would say, a good percentage of them, they're either at retirement age or approaching retirement age already. So we need a lot more new blood, especially in this expanding business. So I think that's all I want to say regarding the background information. So I would like to open up. If you guys have questions, you'll feel free to ask anytime. But I would like to introduce, I know Sam is here. Is Alex here? I think I see one Alex. I don't know if that's the Alex Martinez. Are you here?
Yes, I'm here. Can you guys hear me?
You're here. So you want to go first? If you have a camera, turn on camera and take some time to introduce yourself and how you see the RF engineer field in general. Let me
Sure.
say, Alex has been more experienced student. I think he was working already before he graduated, and then he finished. He took 172. I brought him to Teledyne as a design engineer, and he just got a better offer. After a few years, he is a more experienced engineer before he was graduated, I think. So, okay, Alex, it's yours.
Okay, thanks, Professor. Just a quick little summary of my background. So, just like Professor Kwok said, I worked for GDE. I was an RF intern there for about a year. And then after that, I switched over to L3 Harris. I was a technician there for about 9 months. And that was a really good experience because I got a lot of hands-on hands-on experience there to apply my knowledge that I learned in 140 and 172. And then after that, at some point between there, I finished school and then I started up at Teledyne. And at Teledyne, I was a design engineer for about 3.5 years. And lately, maybe about, what was it? This Wednesday, actually, I just started a new job down south in with this company called Lucix. And I'm doing the same thing still, a design engineer. So why did I choose RF engineering? Mainly for 2 reasons, because it's challenging, but yeah, it's very fun. It's very very physics based, but at the same time the mechanical side is very important, and it's very hands on. So not only do you get to simulate things on software, but you also get to build it and test it. I find that pretty fun. I'll try not to touch on too many things that the professor already mentioned. Like he said, RF engineers are in high demand. I don't know if he mentioned there's a bunch of new startups that are opening up in the space side, like in the LEO and NEO satellites region. Mm-hmm. So there's a huge demand for RF engineers, and what I've seen from my experience talking to companies and recruiters and stuff like that is that companies have a really hard time hiring young RF engineers. That's probably like the hardest market, or the hardest positions to fill. Another reason why I like it so much, because there's just like Professor said, there's so much to learn. You could really go kind of broad, or you could really specialize in one particular thing, like amplifiers or oscillators or synthesizers or whatever. But there's a ton to learn, and you could spend your whole life learning one thing if you wanted to. The other thing, RF is growing. A lot of people, I think there's this misconception or some people say that RF is dead, but I think that's not true because for one reason that there's one thing called SWaP-C, which stands for size, weight, power, and cost. And customers are always trying to, reduce or increase those things, if that makes sense. Size, they're always trying to make things smaller. Weight, always trying to reduce weight. Power, they always want more. And cost, you always want to, go lower. And I guess just the last thing I wanted to throw in there was for job stability. All the senior RF engineers I've talked to in my short career, all of them in their entire career have never struggled finding a job. They've all of them been at the same place for a while, but those who have jumped around, they've never struggled. I think that's about all I have to say.
Okay, so we'll come back
Any
and
questions?
we're gonna have more like a roundtable panel or answer you guys your questions if you have any prepared. So I want to introduce Sam. Where's Sam? Sam, yeah. So Sam is I think maybe only 2-3 years ago when you graduated.
Yeah, I graduated right at the height of the COVID
Right.
shutdown thing.
So and you did not have any working RF experience, right? When you graduated, and
Not
we
at all.
hired you in as a design engineer, and now he just moved on to another company. Also, it's for better, for better environment, more fun. He is one of the smartest students that I had. I think I actually was hitting it up or try to offer him a job before he took 172. So he was like very good. So I let him share his story. Sam.
Howdy, y'all. I'm Sam. Sam, I am. So my background, I graduated 2020. I worked for about a year at Teledyne, thanks to Kwok here opening the door for me. And I worked on sort of RF board level electronics, predominantly amplifiers and down converters or converter up down converters. And then I moved to a new company that was, well, new to me anyway. I moved out of state. So this company now that I'm with called Custom Microwave. And my focus here is more along the lines of what I was passionate about getting into RF in the first place, which is passive components, antennas, filters, feed systems, more of the transmission line, kind of the core of the discipline. And so, yeah. I guess what I would say about RF engineering getting into the field, I mean, I can't really recommend it enough in terms of, job security and such, because both of the companies I've worked for so far the management has explicitly told me that they just cannot find young engineers who have enough level of competence to be able to bring on board. And it's not something, you do need to have a certain degree of competence beforehand, otherwise you'd just be lost. So I mean, the difficult part about getting in, I would say, is that one, not even a lot of schools offer RF courses. It's so kind of out of vogue these days. And so I think that with SJSU and having Kwok around, it's a good opportunity that not necessarily every college has even. And the other thing that makes RF sort of difficult to get into is that it's not, unlike embedded systems or like analog circuit design, where you can kind of tinker on your own time at home. RF design, because the test equipment and the even just the components and things are so expensive, it's not really something you can kind of tinker with in your own time to any substantial degree. So being able to you kind of have to do it through your job. And I think, again, that's where I would kind of take advantage of the resources that SJSU has in this case, because it's a good leg up that other students aren't going to have. I can even speak from experience that, you know, all of the aerospace and defense companies that come to the career fairs, when I went to a career fair, just saying that I had interest in RF, immediately people would just perk up and say, oh, okay, well, what do you know? What have you taken? You know? So yeah. Everything else has kind of been touched on between Kwok and Alex. So
Yeah, I totally agree with Sam. You got to take advantage of those resources that are being offered, because you don't find too many schools. Even Santa Clara University doesn't teach have any more active microwave RF courses.
and one more thing I should say too is that don't convince yourself that like 140 and 172 concepts are not relevant, because if you want to do antennas, for example, the concepts that you learn, you might not necessarily be chugging the integrals in real life, but the concepts that you learn are absolutely directly applicable to making like even the most basic antennas. And if you're talking about things like, you know, in 140, they talk about reflections off a ground plane from a current carrying wire or something. That current carrying wire could very well be a line antenna, and that ground plane is an approximation of what your cell phone might look like to an antenna. And so that changes the gain patterns of your antenna in ways that you need to be able to understand and predict. And I think if you could kind of put those two things together when you're talking to a recruiter trying to get a job, they would very much take note of that.
So if you guys have any questions for Sam and Alice, please speak up, or for me. In the meantime, I'm going to ask them some questions, maybe that they can share their experience. So my first question would be to both Sam and Alex. You can take turn to answer. So I keep saying for engineers, we don't really just use what we learn in engineering classes, right? I mean, there's a lot of basic stuff that we need. What do you say in your work? How much percentage of your work is really just purely engineer? Let's say you learn how to design an amplifier, you just put in the amplifier design. How much is due to other disciplines like material, thermal, or layout, whatever related? What do you think that percentage roughly is?
You want to take it first, Alex?
Sure.
Yeah, there's a lot of things involved. Just like Professor said, there's a lot of thermal materials, things that you have to take into consideration. I mean, school is just you get a good foundation for the basics, but there's just so much more.
What percentage would you say? Is that like 50% is purely circuit design and another 50% is other stuff, project management, communication, or do you think it's even less?
Oh, yeah, I think maybe about 30%.
30% of,
and it just was good.
30% is design related, circuit related, another 70% is not related. Is that
It can be, yeah. It kind of just it varies, I guess, just from project to project, but
right. Just your experience, yeah.
Right. Yeah, there's so many things that you got, so many, I guess, different hats that you have to wear, from procuring parts to actually testing a part, to building a part. To speaking with the customer, to even getting involved maybe in the sales side. There's so many different aspects that you get exposed to, I guess.
Right. Sam?
Yeah, I mean, you definitely, it's not your entire job is not just strictly related to, design
Mhm.
as per what you learned in school. It depends on your job also, because having had now 2 different jobs in sort of 2 different sub-disciplines of RF, my current job has a lot more emphasis and a lot more time spent on the actual technical details of design,
Mhm.
which I enjoy more. But that said, you're still not isolated from the business aspects of what you're doing, the manufacturability and kind of the physical, pulling the product out of your simulation and into reality. You have to be, you learn a lot about the different types of manufacturing processes that go into it, which types of processes will fit which kinds of designs and their limitations and so on and so forth. And especially with passive stuff and antennas, I mean, it is, if you had to gauge how much the RF engineers talk versus the mechanical engineers talk during meetings, I would say we have like 10% of the total time. We just present the graphs and then the mechanical engineers bicker over screws and such.
Because
But
they
it
are
is very important, obviously, because the physical, I mean, it's physics, right? It is the physical structure is what determines the electrical performance. So just as an example, some like things like surface roughness on
Mhm.
a conductive surface, like an antenna or a filter or anything like that. If it's rougher because of the skin effect, you're going to have more loss. And so different manufacturing methods impart different types of roughnesses. Like you can have roughnesses that are more rounded and roughnesses that are more spiky, and the latter kind of affect the loss in a more adverse way. Yeah, sorry, go ahead, Kwok.
No, my next question would be, students always think I'm throwing them curveballs in the exam. So I want to know in your work, how many curveballs did you see? I mean, do you do the same thing ever? Or do you always doing curveballs?
So I see that kind of curveball sometimes. There's always, maybe not think of it in curveballs, but it's a lot of thinking out of the box, which is it's very fun, but it's challenging because you gotta just think of sometimes novel ways to fix difficult problems.
Yeah, I would second that. The learning definitely doesn't stop at school.
Right.
I get projects handed to me on the daily, about things that I have, other than, kind of fundamental basic things I don't know much about. And so you do have to do a lot of kind of independent research and or reading to kind of get into, to become familiar with particular instantiations of things, and to be able to solve problems. I mean, that's what fundamentally you're paid to do, right? I mean, the amount of time that you kind of spent pondering, kind of maybe a little bit uncertain of what you're doing is pretty significant, I think.
Do you two think our school prepare you enough to do your job? Or at least to
Yes,
get to get you.
yeah, I think so. I mean, just like
so you can learn how to do your job. How about that?
exactly. I think school just teaches us the basics and also teaches us how to learn. So yeah, I think it does just a job and some.
Yep.
Sam.
I think I personally, I am of the belief that the better you understand the theoretical things, the better setup you're going to be at the end. But there are certainly engineers in the field who are more concerned about, practical side of things than necessarily having any kind of deep understanding of the theory. It requires some threshold level of understanding, obviously, but I would say school did a pretty good job. I mean, it gives you the opportunity to enter the job field with a sufficient level of prerequisite knowledge to be able to take off from there. Whether or not you take advantage of that opportunity is up to you, really.
Okay, we have a few students have their hands raised, so I would like to invite them to speak up. I don't have any particular order.
Sure, I'll go ahead.
Okay, you go first.
All right, so I'll just ask two questions for three of you, or especially for Sam and Alex. What was your starting salary when you started, and how much are you making now? And the second question, well,
The
let's
dreaded money question.
You,
I mean,
you know, you cannot ask men about how much they make. It's just like we cannot ask women how old they are.
well,
You
it's
know?
up it's up to them, because one thing that we want to normalize is that's a struggle with students now. I mean, you guys were NCG once, and you know how the struggle of negotiating and not having an idea of like they're taking advantage of you. So that's what we're trying to normalize in IEEE. I mean, I was offered 98K from TI, so I'm just gonna throw that out there. And the other question is that how long did it take you when you started? How long did it take you to feel that you know what you're doing? That like, oh, I don't need any much help from my co-engineers. You know what I'm saying? Like, because at the beginning you feel like you don't know what to do as a design engineer. Like, did it take 6 months, 2 years, or whatever? Thank you.
Okay, I guess I'll give it a crack. Well, for the money thing, it's kind of biased to answer that question, because both me and Sam started our first engineering roles at Teledyne, and unfortunately, Teledyne well, just to sum it up, they're pretty cheap. So there's other companies that pay a lot much more, and they pay
Tell me.
they pay the correct wage. But when I started my gig there, I went in with a mindset that I was going. I guess the money is important, right? But what's even more important is learning as much as you can, because in the long run, the money will come. And I think right now in my current position, I'm not going to give you an exact number, but I think it's
the price range.
It's a pretty. But yeah, it's at least it's above the 6-figure mark. I'll just say that it's somewhere above that. But the next question about when do you feel you're comfortable? Honestly, right now I still don't. I'm not gonna say I don't feel like I'm comfortable, but I'm always gonna be learning. What's the word I guess I'm looking for? Kind of back to just what Sam said. I mean, you learn the basics, and you kind of just build upon that. Or you want to elaborate more on that, Sam? I guess probably.
Sure. Sorry, there was two parts of the question. There was the money part, and there was what was the second part?
How long did it take you to
Yeah.
get comfortable?
Sure. Well, I'll answer the second part first. I definitely felt like the first 6 months of my job, my head was barely above water in terms of what I was able to comprehend and kind of understand on a day-to-day basis. It took a long time for me to get to be able to synthesize all that information and kind of correlate it back to what I learned in school in any kind of meaningful way. I would say, yeah, I would say probably 6 months before I kind of stopped feeling like I was drowning. So I feel pretty comfortable. I'm at kind of the 1.5 year point now. And even though I moved from board level design into more passive antenna levels, or, you know, E&M style stuff, it carried over pretty well for the most part. I do feel pretty comfortable now. However, I mean, I should kind of qualify that with that. I still ask my coworkers questions all the time. And I don't know necessarily if I'm still doing things that I'm uncomfortable with, right? I'm just not like drowning about it. You know, and frankly, if you're doing it right, you should always be doing something you're uncomfortable with, because the minute you kind of get complacent and start to rest on your laurels, I mean, you kind of get irrelevant, and that's, I don't know. Yeah, I get bored very easily. So I kind of constantly need that stimulation to be learning new things like that. And I mean, the job certainly gives you the opportunity to feed that. As far as the money is concerned, I would also have to agree with what Alex said about I'm kind of playing the long game myself. I didn't get into engineering for the money per se. It's a convenient bonus. I got in it because, again, there's a lot of really boring jobs out there where you could just show up and clock in and clock out and space out for half the day. And considering how much of your life is spent at work, that just wasn't acceptable to me. So I get paid certainly less than a software engineer would, but I think the RF engineering field, you know, is generally within the field of electrical engineering, one of the better paid disciplines. And especially as you get towards a senior level position, I mean, it's not uncommon for senior level RF engineers to be making like mid 100 level salaries, right? So, you know, in the 150 range. So as far as I'm concerned, I make about half of that right now, and I'm certainly not hurting for money. I just bought a house here in Colorado, so I'm comfortable. I don't really care. The difference between 75 and 90 is a lot less important than the difference between like 45 and 60. You know what I mean?
And after tax, it doesn't make that much difference.
Yeah.
Really, seriously.
Yeah, and like after like what Sam said, like after you get past like that like 2 year mark, 3 year mark, it gets kind of your wage it kind of starts to grow a little bit exponentially. So
Right. I mean, get a job and get good at your job. Focus on growing your skills. And when you have skills and you're able to demonstrate that,
yep,
people will pay you. Like, there's no doubt about it.
people will pay you. Exactly.
All right. Well, thank you, Alex. You're next, since I'm keeping track of the order of raising hands here.
Sure, yeah. So you guys have piqued my interest. So now I'm curious, as an undergrad doubly, what resources at JSU you are referring to, specifically the class EE 172, or can you elaborate on that, please?
Yeah, 172. I know we're kind of lacking some of the maybe equipment, but he does have a working network analyzer. So, and I think the communications lab also has more equipment like spectrum analyzers and stuff like that.
Okay, all right. Sounds like that class or grad stuff.
There's also some RF equipment in the communications lab. And in fact, I should say that having not taken communications, so I think that's 160, if it's still the same number, rather than taking controls, which is 132. I think having taken 160 would help you from a systems level understanding to understand sort of at the RF level, it's a little bit lower to the ground, so to speak. You're more in the physics of things or the circuit level of things and not necessarily thinking about like the applications of what you're doing at all times. And I think that taking 160 and even learning how to use like some of the lab equipment in there that like a spectrum analyzer would be helpful.
Okay, very helpful.
Yeah, you get a pretty good system wide. Oh, go ahead.
Yeah, so with 172, I'm looking at just the intro to the class here. How did that fit in with, I mean, RF is a huge field, right? So that class, what niche or area does that kind of fill or talk about?
Passives. It's almost exclusively passive. And that was probably one of the bigger hurdles when I got hired at Teledyne for doing RF circuit design, which is all obviously active components. So it is, the fundamentals are the same, but it's, you know, it's not entirely overlapped.
Okay, so that's more like what you're doing now? And
Yeah.
by passives, you mean the design of
The design of
components
filters,
see.
power dividers, basically everything that has to do with the transmission line. And although they don't explicitly go into antennas, I would say that it's what you learn is more applicable to antenna design in some sense than it is to like RF power amplifier design. RF power, like I know that's what you focus on, Alex, is the actives, if you want to speak to that, but I could just say that RF circuit board design is sort of somewhere between 172 and like what you see in a traditional analog circuit class. It's like a traditional analog circuit class with the RF layers built on top of it. So it is a little bit more complex than that. But
Okay, thank you.
Yeah, and in 172, you also get exposed to, you also learn about S parameters, network analysis, and that's that's pretty important. A lot of fundamentals that are amplifiers, oscillators, and or based off of.
Cool, thank you.
All right, Matthew.
How are you guys doing?
pretty good. How are you, man?
Doing all
Good.
right. So I'm doing all right. So I have a few questions. So I understand RF is more about. So is RF more about sending information like at like high frequencies?
Yes. And
Okay.
in particular, the physical layer of that. So if you were to break down a communication system, it's very towards the bottom layer of that communication system. So it is, like I said, it's physics, really, at the end of the day. It's applied physics.
Yeah, I can see.
Yeah, you're talking about everywhere. Sorry, you're talking about anywhere from low frequency, 300 megahertz, radio stuff, all the way up to light. So it's pretty broad spectrum.
DC
Yeah.
to daylight.
Hello?
Yeah.
Oh, okay. Yeah. My other question is, let's say we don't have a whole lot of like technical experience with RF, but we want to get into it. Like, what would you suggest we start from in terms of, is there like online software that we can simulate like RF circuits?
That's part of the tough part that I was talking about. A lot of the tools to do RF analysis are expensive and kind of hard to get access to. I would leverage as much as you can through the school, especially if a few programs, just to throw some names out there, if you wanted to do your own research into how you can get your hands on them, is HFSS or CST. we also use Microwave Wizard at my work a lot, although that's more specifically like,
Microsoft Office, or is it?
oh, Microsoft Office as well. Yeah. I forgot
Mhm.
about that. That's a pretty big one, but
So software we have in SJSU, we have software that you can use in the computer lab.
Okay.
You can also get HFSS. We have ADS. Microwave Office you can download into your computer. For the equipment,
But think you
there are
can
new
also
companies making a cheap network analyzer. It's like $200 range. It's very
Mhm.
affordable. You can hook up to your laptop. And
Okay.
yeah, so last semester we have a student, a couple students bought them. It works fairly decent.
That's nice. Yeah.
Yeah, so something.
Yeah,
yeah.
Analog Devices makes a radio SDR called the Atom Pluto. So that's it's a pretty fun little SDR radio. SDR stands for software defined
Software
radio,
defined radio.
and it's super cheap. It's relatively cheap. It's $100, but for a little radio, that's pretty cheap. And you can play with it with MATLAB, Simulink. You could code in C, C++. It's super user friendly. There's a lot of documentation online, so that might be a little some similar to start off at. And again, that's I believe it's Atom Pluto, and it's made
Atom,
Can
it's
you-
made by
Pluto.
Analog
Yeah,
Devices.
can you type it on the chat, please? Because we have some
ADL?
ADI connection. We might be able to ask some donations from them.
Because I think I've used Pluto in the past for E160.
Yeah, I think Professor Morales is starting to use that radio too.
From Analog Devices.
Correct.
Okay. So my other question I have is, where would you recommend us to start in terms of position, like testing, design, or manufacturing? Which position would give us like the best chance to learn about RF and how it works?
I think that definitely doing some. I had the fortune of being hired on as an RF design engineer, but at Teledyne it required a lot of actual hands-on like tech work, and that was pretty invaluable. And compared to the younger engineers who I work with now at my new company, that's definitely an experience that they don't have. So I would say, yeah, doing at least tech work in some capacity at first can really go a long way in helping you kind of put the book knowledge, connect the book knowledge to what you're doing.
Okay.
Yeah, tech work, or maybe like a manufacturing engineer position or something like that would be super helpful.
Okay. My last question is, where do you see the future of RF? Like in terms of machine learning, AI, quantum computing, and stuff like that. If you
Well,
can.
kind of like Professor Kwok said, there's a lot of, I think it's going everywhere. It's gonna, a lot of markets emerging. So machine learning, quantum computing. I know I've seen a few AI and quantum computing companies looking for RF engineers. So it's just one example.
I mean, everything that's wireless needs an RF engineer, or if the company doesn't have one themselves, then they're contracting out to another company that has RF engineers. So as far as how that directly will impact, I mean, I don't see the demand for RF engineers going anywhere but up in the future, because as Kwok said, I mean, everything is connected now. And on top of that, RF design is becoming more challenging because as more and more devices come online, they're competing for the same bandwidth, and you need to meet harder specs. So your devices need to communicate over a finite resource, a finite, frequency band. So as the competition in that space grows, they're not making new, you can't make a new frequency band, right? Like the government opens up new bands every now and again, but ultimately it's a finite resource, same as the land on Earth. You know what I mean? It cannot be made more of. And
I mean, someone might also say you can go up in frequency, but there's also a lot of challenges in going up and making things that operate at higher frequencies.
Until someone invents an optical transistor, I wouldn't worry about RF going anywhere.
Yeah, that's very well put. Thank you, guys. Appreciate it.
All right, yeah, I had a question. Are there any specific courses or skills that you wish you had invested more time into, like before you started your job?
I wish SJSU had a better, had more RF courses in the grad level, at the grad level, sorry. That's my take.
I mean, I wish I had taken 160 instead of 132, I'll tell you that. But other than that, I mean, I think, yeah, just take as many RF courses or classes that are cursory related to RF, like signal processing is another. It is not RF engineering, but a lot of the core theory and concepts can carry over to some degree to RF engineering.
So it's a demand and supply thing. San Jose State used to have, I think, more RF courses than what we have now, but the number of enrollment has dropped, and so the school also, facing financial issues, they cancel a few classes. But it's something that you guys are, if you are interested, you should bring it up to the school and say, hey, we really want to see more RF courses. Of course, by the time said and done, it probably won't really benefit you, but it's still, they need to hear your feedback. Right? And the feedback cannot be from me, because they will say, well, you are just self-serving.
I see a question here, just quickly to address how much DSP is used in RF engineering. Strictly speaking, RF engineering and DSP are not the same field. They're not in this. DSP is not a subset of RF engineering, but when you're talking about communication system, typically you're going to have an antenna system with a feed system at the front end of, and then that's going to actually get radiation from the air or water or whatever the hell you're usually air, right? Or space vacuum. That's going to then be moved into the RF circuit domain, where they're going to take that high frequency signal, convert it down so that it can be processed by traditional analog and digital circuitry. Then it's going to be sampled on an ADC. And then you'll do DSP on that extracted waveform to, decipher the message and what from sensor another.
Well, there are talks about using DSP, pushing it to higher and higher frequency. So you'll strip it down, but it's still far from what they can do in the frequencies that we are interested in. So right now it's still in the baseband type of processing.
All right, iPhone. You're next. Hello, iPhone.
iPhone. Hey Siri.
Right. Okay. iPhone, if you are not ready yet, I mean, others can ask questions.
Where can we find a recording for this meeting?
Oh, We will announce it on IEEE Discord. We'll try to figure out. Maybe we'll create a YouTube channel and we can just put all our recordings there so you guys can access it.
Oh, what channel again?
Go to our IEEE Discord channel for now, and we'll do the announcement where we post the recordings.
All right.
Thank you.
Oh wait, where's the triple IE again?
I will put it on the chat.
In the Discord for E140.
All right, that's the main IEEE Discord where we post announcement and chat with other students. iPhone, are you ready to ask now? If not, anyone else have any other questions?
As ending remark, I actually want to second what Sam said earlier. When you are working as an engineer, you should feel a little bit uncomfortable. I mean, you don't want to do things that you feel so comfortable that you just repeat it every time. If you are too comfortable, that means you're not pushing the envelope. You should always constantly thinking of how can I do better? How can I do better than a competitor? How can I make it smaller, better, cheaper, higher power, whatever. So, and because of this uncertainty, yes, there has it comes a little stress, right, with it. But that's part of the interesting or exciting part about working as an engineer, I think. So.
I have a question.
Yes.
What is your least favorite? Because like all the things that we hear, like you enjoyed all these things, nerd stuff about RF. Do you ever have any like least favorite part of your job? It doesn't need to be nerd stuff, but like in the real life.
Sam?
As an RF engineer, I think, or just like anything else, there's always some things that we don't really like doing at work. Me, for example, is there's some paperwork or some paperwork related tasks that are, it's not fun, but it needs to be done. So I guess that's my answer on that.
Yes. Basically, all the technical stuff I enjoy. It's all of the stuff that supports that, all of the anything related to the business operation or project management side of things. I dread it, but hey, take the good with the
same here.
But some people actually would like that, right? I mean, that's why we have different people want to be a different type of engineers, right? Some people like to deal with people. They like to meet. They like to go to meeting all days. They should be a program manager. But if you are a hardcore designer, you like to play with technology, then that's not, perhaps it's not something you want to do.
How many hours do you guys work a week?
Oh, you know what? This is kind of going back to your question about salary. But if you're really in it, if salary is a motivator, I know in sales for RF engineering, there's a lot of money there because there's
No, it's not about the money that
commissions and stuff like that.
It's not about the money that just the work balance, work-life balance in like. I want to have an idea how much workload you guys have, or are you guys able to have the work-life balance still?
It all depends.
Yeah, it kind of just depends on your place to place, but my average work hours is about nine hours a day.
All right,
Yeah.
thank you.
I do pretty much 8 hours a day. And
I average more, I think, but it's not that because I have to. I mean, in a lot of cases, I can turn them down, but I enjoy what I do, and so I tend to do more. Although there are parts like part of the business thing that I don't enjoy, but a lot of the new design that I want to see it done. I want to try new things, so I'm willing to put in time. Now, if I'm busy, I can cut those off easily. I have a lot of other gigs that I do on the side that's not working. I still have time to do, like teaching, for example, right? They allow me to take my time to teach. I also do a lot of other stuff on the weekend. So I work a lot, but I also have the flexibility to take off whenever I want to or whenever I need to.
All right.
So,
Yeah, I think it kind of does follow the stereotype of like a smaller company typically will require you, or at least I shouldn't say smaller company, but a less established company is going to work you a little bit more and pay you a little bit less probably than an older company and a larger company.
And you guys mentioned that you just got a new job from different company. Is it correct? Any particular reason that you guys might want to share that why you, if you really enjoyed what you're doing at that moment, then what's the reason why you guys moved somewhere else?
Reasons for moving? Because the work culture changed. It became toxic. When I initially came on board at Teledyne, it was good, but management changed and things kind of went downhill. And the writing was on the wall, and you had a lot of people leave and whatnot.
In my case, I wanted to focus on passives more than anything. And on top of that, I didn't really like how much, when you asked earlier about the parts of the job you don't like, I felt like that was dominating a lot of my work hours every day. So I wanted to go somewhere I could focus more on the technical stuff.
I think both Sam and Alex are moving up in their career. They find something they like to do better, of course, with a little better treatment also. I mean, that's natural growth, right? I mean, if you stay in the company too long, it's not necessarily a good thing, especially for a young engineer.
I can throw out there too.
Go ahead.
I was going to say, if anyone, I mean, once they graduate, is interested in moving out to Colorado, my company is pretty hungry for engineers, to be honest with you.
How about internship? Like,
I don't know. I don't think they have had internships in the past, but I can always talk to my boss. I work for a smaller company, so it's a pretty approachable environment. They're pretty open.
sure, we'll keep in touch then. Yeah, I didn't mean to like ask you guys a hard question or whatever. I mean, these are really very helpful information coming from you guys, and because you're just a bunch of confused students and doesn't know what we're up to after school, right? So Alex, you have a question?
Yeah, so I think Kwok started to say something there at the end that challenged an assumption that I've had for a while. I have a career already in IT engineering, but the concept I had is that if you move jobs too often, in Silicon Valley, there's a little bit of that, get a job 2 years, move 2 years, move 2 years. But that if you do that too much, it becomes a red flag. So I'm hearing now maybe a different side about maybe it's better for an engineer to move around a little more. Can you please elaborate on your thoughts on that?
So I think, especially for young engineers, I think you should move, I think within like 3 years, because companies this day, they don't really take care of you. They would rather, and they rather hire someone with a lot more money than raise your salary organically. Unfortunately, that's just the culture. And you, if you really like that company, I would suggest you to move out and then come back again in a few years. That would be part of it. You also gain because you're not so tuned in just doing things one way. You actually go out to see the world, to see how other people do things. So you gain in terms of experience, and that experience in turn would help your company. So moving around is not a bad thing, especially our field is so hungry of engineers. I actually encourage younger engineers to move more often.
I get LinkedIn messages pretty regularly
Yeah.
about people reaching out for different jobs that they're looking for. And to speak to what you said about the raising of salary though too, and kind of the work-life balance thing, again, one thing I guess that came to mind is your salary is not your total compensation. And so you should kind of be, a salary is like the sticker price. It doesn't include all of the other things you get. So for example, at my job, my salary is probably not that impressive by a standard, but I also get like 20 something days off a year of paid vacation, which is like, at my last job, I would have had to work, I think I would have had to be there like 10 years before I got that amount of vacation time. So, it all depends on what you value in that case.
Okay, thank you for sharing. That's very helpful.
Good.
So can we keep in touch with you guys for like in the future if there are, networking wise, if there are opportunity at your company, or if you guys are looking for engineers, we can announce those opportunity through IEEE or through our university.
Sure.
Sure.
I want to before we end, I want to thank Sam and Alex taking their time to join us. I think their information is very valuable to our students, much more than I can ever offer. So thank you.
We're only here because of you.
Thank you,
Yep.
Sam.
Thanks, Sam. Thanks, Alex.
Yeah, thank you, Professor Kwok. Thank you, Sam, Alex. I mean, this really, really means a lot to everybody. I mean, again, I keep emphasizing we're just confused. We need all this information from you guys. We don't know what to do from here.
You are doing well. You have things lined up. It's really good. And I do want to thank you for putting this together. I think that's very useful and helpful. Yeah, for a lot of people. So thank you.
Yep, thank you. And to everybody, thank you for showing up. Well, this is a record-breaking IEEE event that we have. We hit 42 attendees tonight, and we'll try to post the recordings as soon as it's available, and we will announce it on the IEEE Discord. Sam and Alex, where do we get your contact? Do I just get it through Professor Kwok? I don't know, or
Yeah. Yep.
Yeah.
okay. All right. Thank you. And you guys have a great evening. If you guys are taking EE 124, 122, 110, we have a tutoring session at 7:30.
Thank you.
All right. Thank you. Bye.
Good night, everybody.
All right, you guys have a nice weekend.
Thank you, Alex and Sam.
Thank you. Adios all.